HVAC temp rise formula for measuring airflow cubic feet per minute gives accurate system airflow when you place the temperature probes correctly and account for heat strip and radiant heat bias. The correct method is to measure the supply and return air temperatures at representative locations. Measure the return at least 6 inches into the return plenum away from filters, and measure the supply at least 6 duct diameters downstream of bends or transitions. And for systems with electric heat strips, you must move the supply probe at least 2 to 3 feet downstream of the heat strip to avoid radiant bias. Calculate temperature rise as supply temperature minus return temperature, and then compute cubic feet per minute using CFM equals heating output divided by 120 for Fahrenheit degree-based constant times the measured temperature rise when using British thermal unit per hour inputs, making sure the heater capacity used is the delivered sensible heat, not nameplate gross capacity. For accuracy, use a calibrated thermocouple or digital thermometer with at least plus or minus 0.5 degree Fahrenheit accuracy and sample for 20 to 30 seconds, while holding the probe midpoint in the duct cross-section, or take a 3-point average across the duct to avoid stratification errors. When measuring small ducts or low airflow, correct for probe intrusion by subtracting the obstruction percentage from flow calculations. Or better yet, use a vane meter at the grill. Log ambient and system runtime conditions and repeat measurements after 5 minutes of steady state to avoid transient heat strip cycling effects. Document probe locations, distances from heating elements, and calibration stickers, so future techs can reproduce the test. When using the temp rise method for diagnostics versus commissioning, factor in humidity and latent loads, because latent heat changes can make apparent sensible heat lower and give an overestimated airflow if uncorrected. One of the biggest mistakes is measuring supply duct temperature too close to the heat strip, which causes radiant heat bias and higher than actual air temperature readings. Fix it by moving the probe at least 2 to 3 feet downstream or beyond the immediate radiant field and average multiple points. One of the other common errors is using uncalibrated thermometers or single-point readings, leading to inaccurate delta temperature and wrong cubic feet per minute. Fix it by using a calibrated probe, sampling for 20 to 30 seconds, and taking a 3-point cross-section average. One of the third frequent problems is using nameplate heater capacity instead of actual sensible heat output, which skews the CFM calculation. Fix it by measuring actual delivered heating output or using manufacturer sensible heat curves, and correct for latent loads. BigHomeProjects.com lists verified heating, ventilation, and air conditioning professionals so homeowners can find trusted local contractors who know proper temp rise and airflow test techniques. The directory helps contractors get work by showcasing credentials, reviews, and measured service specialties, so qualified techs connect with customers who need accurate HVAC diagnostics.